can learn from such sites because they are analogous to the hydrothermal conditions 4 billion years ago, when life began on the Earth and perhaps on Mars. One of the distinguishing characteristics of vents and fields is the complexity of interfaces found there. Vents have a single interface between minerals and seawater, while fields have 3 interfaces that undergo continuous fluctuations: mineral and water, mineral and atmosphere and water. As will be discussed in later chapters, the physical and chemical processes that occur at fluctuating interfaces are an essential part of the hypothetical scenario being developed in this book. The second distinguishing difference between vents and fields concerns ionic solutes in the water. Seawater has a relatively high concentration of sodium chloride and divalent cations like calcium and magnesium, and these strongly affect the self-assembly of amphiphilic compounds into membranous compartments. In contrast, the water of hydrothermal fields is essentially distilled water produced by evaporation of seawater and precipitated as rain on volcanic land masses. The acidity and alkalinity of the water are also important. Some hydrothermal fields are acidic, pH 2 to 4, due to the sulfur dioxide and hydrochloric acid vapor that dissolves in the water, while others are in the neutral pH range. The aqueous fluids of hydrothermal vents have a much broader pH range, from pH 3 for black smokers to pH 10 through 11 for alkaline vents. In a later chapter, we will discuss how pH strongly affects the kinds of chemical reactions that can occur between organic solutes dissolved in water. Finally, we need to pay attention to the composition of minerals that come into contact with hydrothermal water. The primary mineral surface associated with volcanic hydrothermal fields is basalt, but over thousands to millions of years of exposure to acidic hydrothermal water, the basalt slowly weathers to become microscopic particles of various clays. The adsorptive properties of clay interfaces have been the focus of many earlier studies, but here the focus will be on the physical properties of clays as sealants of otherwise porous volcanic minerals. The minerals of hydrothermal vents have significant roles in the speculations that life could emerge in the chimneys of black or white smokers. Particular emphasis has been given to the fact that black smokers have abundant iron sulfides, and that iron-sulfur complexes are present in at least 16 enzymes, such as hydrogen dehydrogenase, carbon monoxide dehydrogenase, and the ferredoxin in nitrate reductase, and glutamate synthetase. It is possible to imagine that such enzymes were active in primitive forms of microbial life. Hydrothermal fields are a plausible alternative to hydrothermal vents as sites for the origin of life. The measured pH of hydrothermal water accumulating in basaltic mineral basins is low due to acidic components of volcanic vapor that dissolve in the water. This acidic pH is significant because it is related to the availability of phosphate, which is limited by the fact that when calcium and phosphate are mixed in neutral to alkaline pH ranges, a highly insoluble mineral called apatite is formed. However, the acidic water of hydrothermal fields would readily dissolve apatite and make soluble phosphate available for phosphorylation of organic compounds, an essential first step toward primitive metabolism. Microscopic parameters, properties of minerals. The third scale to consider has dimensions measured in micrometers and can be investigated using light microscopy. Glass containers are commonly used in laboratory simulations of prebiotic conditions, and microscopically, glass surfaces appear entirely smooth. This is acceptable if the experiments are being done in solution, but with the possible exception of obsidian and mica, there is no equivalent of smooth glass in natural conditions. Instead, the most common mineral surfaces on the Earth 4 billion years ago would be volcanic ash, cooled lava, and pumice. However, these are dry surfaces, and the sites we are considering as analogs for the origin of life are today's hydrothermal fields. Imagine